So here's your video for relations and functions. These are notes 11-14. You got the handout in class. We are marking it as page 68, I believe, and the date you are putting is tomorrow's date, which is 3/13. Relations and functions. A couple things about them. So definition, a blank is a pairing of numbers in one set. It's a relation. It's like a group of numbers or a group of ordered pairs. Number 2, the blank is the set of all possible inputs. Input being the key word there. That is our domain. And then the blank of all possible outputs is our range. So saying this the opposite way, each number in the domain is called an input. It's all of your x coordinates. And each number in the range is called the output, and so that is your y coordinate. A relation is a function if for each input there's exactly one output. And then something that's really going to help us save time is called the vertical line test. The VLT says that if you can find a vertical line passing through more than one point of the graph, then the relation is not a function. So example number 1, yours may look a little bit different. Your table may be horizontal instead of vertical. It says identify the domain and range of this relation. So the relation is just a group of ordered pairs. And the domain is all of the x coordinates. So we have the set 1, 2, 3, and 4. Those are all of the inputs. And our range is all of the y coordinates or the outputs. We have 23, 36, 47, and 61, our domain and range. Example number 2 says, relations can be expressed in many different ways, such as we can have it be a graph, because we can plot ordered pairs on a graph. We can have it be a mapping, or we can have it be a table. So here's our relation, -1, 1, which is here on our graph, 2, 0, which is here, 3, 2, and 4, 5. So that's one way to demonstrate a relation by putting it on a graph. And something later in the video that we're going to talk about is the vertical line test. And the vertical line test works like this. If I can draw vertical lines through this graph without touching more than one of the ordered pairs in one of my vertical lines, it passes the vertical line test. And so we would say yes, that this is a function. And we're going to do more of those on the next page. When we're doing a mapping diagram, we put all of the x values or all of the inputs in one bubble. And if there are repeats, we only write them once. And then we put all the outputs in the opposite bubble. And then we just draw an arrow to show what goes with what. That's our mapping. In a table you've seen many times, we write the ordered pairs as an x coordinate and a y, like so. So those are the 3 different ways to write a relation, and all of this set or this relation is a function. So example number 3 talks about the vertical line test and drawing a mapping to tell if it's a function. It says not every relation is a function. None of the outputs can be repeated. So it's all about the outputs being repeated in order for it to be a function. Determine if the example below are functions. Draw a mapping diagram to help you. And I would like you to change this. This is a typo. This should be none of the inputs can be repeated. So we cannot split an input into two separate directions. And we'll come across that example in choice B. So let's do the mapping for A. It says -3, -2, so those two go together. -1, +4, and 6 with the 8. So there's our mapping for number 1. You see how each of the inputs is going to directly one output. So this yes is a function. And if I graphed each of these ordered pairs and I drew any vertical line on the grid, it would only hit one of the points. So it passes the vertical line test. Letter B says -3 goes with -2. It says -1 goes with 4. But it also says -1 goes with 8. And we cannot have that happen. This -1 cannot be split into two separate directions. So this is no, it's not a function. And if I drew a little sketch here to show you the graph, the vertical line test, -3, +2 is somewhere here. -1, 4 would be here somewhere, and -1, 8 would be up here. And when I draw a vertical line through this information, I hit 2 points just in this one vertical line here and here. So it fails the vertical line test, so it is not a function. And part C says -3 goes with -2, -1 with -4, and +6 also goes to -2. Now that is okay because the y coordinate has two x values, but none of the x coordinates are being split into two separate directions. They are sharing a y coordinate, that's okay. And you notice the difference from letter B, or part B, that the -1 was being split in two different directions. None of these x coordinates are being split apart. So this is yes, a function. So for example number 4, part A, I want you to add the parabola, and we've talked a little bit about parabolas before. I want you to draw a parabola, just a sketch, on your coordinate grid there. It says determine if the examples below are functions based on their table or graph. And so I am going to use the vertical line test for part A to determine if this is a function. So I can draw any vertical line, and I only hit the graph in one spot. Vertical line, I hit it in one spot. Vertical line, I hit it in one spot. Each of the vertical lines are considered a separate test, and I only want to hit the graph in one particular spot. So this is yes, it is a function because it passes the vertical line test. Now if I went back and in a separate color, I'm going to use yellow just to show you. You don't have to write this down, but I want to show you if I had something that looked like this as my graph, and then I tested with the vertical line test. Right away, I hit the graph in two separate spots. This yellow line, this is not a function. It fails the vertical line test. For letter B, I am looking at an x coordinate that is being used two separate times. So this is not a function because that x coordinate would be split in two different directions. It would be going with the 2, and it would also be going with the 0, and that does not work for a function. So two questions about the vertical line test, C and D. It says, would the graph of y equals -6 pass the vertical line test? Well, if I sketch the graph of y equals -6, it's going to look like this. Here's y equals -6. Is it going to pass the vertical line test? Yes. And the graph of y equals, or x equals 3, will that pass? Well, here's maybe where it would be. X equals 3. It's just a sketch. Well, if I draw any vertical line there, it's going to hit every line on that graph, So this is no. It's going to fail the vertical line test for x equals 3. And that is the end of your notes for today. Please copy those down onto the packet. It's page 68. The date is 3/13. And we will move on with functions tomorrow.